So I'm a PhD student at the Department of Electrical Engineering at the University of Massachusetts Amherst. So today I will talk about digital wallets and how we make transactions and how we can make them secure. So almost everybody must have used a digital transaction, like using their smart card or a payment card or credit card. You can use this by tapping it on a POS, point of sales terminal machine, or by swiping it or by tapping it, right? And with these physical cards, we always feel a fear of theft, or there is a fraud being committed online, or somebody could skim that card, right? We need a place to securely store these cards. And this is where a digital wallet comes in. For example, Google Pay, and we have Apple Pay as well. They are ubiquitous. You can use them anytime, anywhere. They are convenient to use, but are they really secure? And today we'll explore that. So to study this, we look at the EVM protocol that actually governs the communication between the wallet and the bank, and how the user is involved in the process. So the process starts with the user, and the user enters their card in the wallet and then use it for transaction. They can either use a POS terminal to acquire the transaction, or an online merchant where you can pay with PayPal, for example, or you could simply just use Google Pay or Apple Pay to pay in an app or a website. And the transaction goes to the bank, where it verifies that everything is OK, and then they settle the payment. So you can see that the transaction starts from the user, who is actually the authorized person to use that card and who has the ownership of the card, and the bank that issues the card and is responsible to making it secure, right? So we would expect that these two would get the lead in making this whole loop a little bit more secure, but that's not actually the case. So how we study by looking at the EVM protocol is that the bank actually delegates the choice of authentication method to the wallet. So whenever you're adding the card to your Apple Pay or Google Pay, you can see that whatever authentication mechanism that is used, actually the wallet is in charge of that, and what method is essentially being used. So wallets tend to use KBA, which involves verification through billing address, zip code, date of birth, or last 4 digits of SSN. Right, there are also MFA-based, like OTP-based mechanisms, either through SMS, call, or email. But in this day and age, even Facebook or Instagram, these kind of platforms don't even use KBA. So why the banks are still allowing KBA to add these cards to digital wallets, right? So in our attacks, we show that the delegation of authentication actually allows the attacker to add a stolen card to their wallet using a weaker authentication, because billing address, zip code, date of birth is very easy to acquire through online databases and through social engineering, right? So now once the card is added to the wallet, and this could be added to a malicious wallet through an attacker, you can assume that you can lock the card to block any transaction, but that is not what's happening. So you see that there are 6 banks that we have studied. And once you lock the card, the physical card cannot be used to make transactions. But you can use the wallet to make the transaction still. And some of these banks actually don't allow the in-store transaction, the one-time transaction, but the recurring transaction, the subscription that you set up through Netflix or something else, that will still go on, even though you have locked the card, and you would assume that now the whole loop is secure, but that is not the case, because the wallet is in charge of making that transaction, and the bank is allowing that to happen. So the user does not have a control of how the wallet operates, essentially. And the banks have established an unconditional trust on the security of the wallet, which we've shown that can be circumvented. So now once you say that, OK, my card got lost, I want to replace that card, right? So you contact the bank, and they issue another card. So what happens is the bank, for your convenience and for a better user experience, they would automatically update that card in the bank, and they would not involve any user to make any verification of if this is still the secure and a legitimate wallet or not. So in case that attacker has already added your card to their wallet, this card replacement update will get to the attacker's wallet as well. So the attacker will get an indefinite access to your card even when you actually replace the card and you get another physical card. And this is very concerning. So what is our solution? We are asking to bring the human back in the loop. So whenever you're adding the card, just like any other platform, like Facebook or Instagram or Twitter or whatever, you get to verify if it's you who is logging in, right? And also whenever there is a card being replaced, at least the user gets to choose if what wallet actually get this update or not. Yeah, that's basically it. Thank you so much. And if you want more details on these attacks, please try to come to my talk tomorrow at USENIX.